Hi, I hope you're doing well today. Today we're going to focus on quadratic regression. The first example we're going to use says online shopping has experienced tremendous growth since the year 2000. One way to measure the growth is to track the average number of daily hits of the websites of online stores. The tables show the average number of daily hits for 3 different online stores in various years since the year 2000. So we're going to be looking since the year 2000. Let's focus on this middle table. And this store is called eBay. What we want to do first is to sketch a scatter plot. So the years since 2000, this is your X. The daily hits in thousands, this is your Y. So if we plot 0, 1, just estimate, 2, 4.9, 4, 17.2, 6, 37.2, 8, 64.9. The function type that we are looking at is quadratic today. Quadratic. The ways that we can tell or to identify that this is a quadratic function. The first way is to look at your table. So table. The second differences are fairly constant. So the second differences are fairly constant. So your second differences are fairly constant. So let's take a look at what this means. Let's go and look at the table again. If we look at your Y row, the first difference we would have 3.9. Find the first difference for each of these, 17.2 minus 4.9, 37.2 minus 17.2, and 64.9 minus 37.2 is 27.7. So that's the first difference. If we look at the second difference, 12.3 minus 3.9 is 8.4. 20 minus 12.3, 7.7. And 27 minus 20, 7.7. So the second time that we take the differences, these are fairly constant. Another way to identify a quadratic function is looking at the graph. You have a parabola. We have a curve. And this curve is going to constantly increase or decrease. So it's constantly increasing or decreasing. So for a graph, you have a parabola. The curve is constantly increasing or decreasing. The third way to look at the function is by the form, your standard form. Y is equal to ax squared plus bx plus c. Let's look at finding the equation of best fit. So we have determined that this is quadratic. So what we would want to do is to take your table and enter this into the calculator. So you would go to your Stat, Edit, and type in your to list. So you would enter your to list. Because this is quadratic, we're going to do quadratic regression. So we would press the Stat button, go right to Calc, and number 5 is the quadratic regression. Make sure your list, mine are L1, L2. So I will calculate this. And then I'm going to write the equation now. So the equation of best fit, y is equal to 0.9875 x squared plus 0.105x plus 0.92. The next thing we need to look at is something that is called interpolate and extrapolate. If you are inter, you are within your points, your data points. If you are extra, you are outside of these points. So we want to predict the number of daily hits for this store in 2015. So X is going to represent the year 15. If we look at the information from the table, 15 years since 2000, we're going to be outside of the X values. So this is an example of an extrapolate. So if we plug in 15 for X, and evaluate this, we get 224.6825. So this would be approximately 224.7 hits in the year 2015. All right, let's look at two additional examples. Let's look at this first example. It says the population of Williston, North Dakota has grown rapidly over the past decade. The table gives the population of the town in 2007, 2009, and 2011. So this is your table. Let's enter this information into a list. You will need to make sure that you clear out the two lists you had entered for the first example. So I'm going to go ahead and enter L1 and L2. You can do that as well. So here's the information. Part A wants us to sketch a scatter plot to determine if we have linear, quadratic, or exponential. So if we do stat or second stat plot, make sure your stat plot is turned on, and then zoom. Option 9 is your zoom stat. So we have an example of a quadratic function. So 1a is quadratic. second thing we're asked to do is to find what is the equation of best fit for the data or data. So since we've determined this is quadratic, we'll do stat, go right to calc, option 5, quadratic regression. Make sure your lists match up. So I'm going to take this information and write the standard form. And this would be minus 4.5x plus 29.2. C wants us to predict the population in 2010, and is this interpolation or extrapolation? So if we look at the year 2010, we're going to let x be 10. And when we evaluate this, after plugging in the 10, we get 14.2. So the example would give us 14,200 for the population in 2010. And if we look at your list, 2010 would be between 9 and 11. So this is an example of interpolation. D wants us to find the year 2020. So we would let x be 20, plug in 20 for x, we would get 59.2. So the population would be 59,200. Looking at your table, the year 2020, 20 would be after the 11. So this is an example of extrapolation. Okay, the final example that we are going to look at, we have Timothy Donovan's 10K run. The distance in minutes or distance in meters for the y value, and then the time in minutes for the x coordinate. I want you to put this information from the table into your calculator. And I want you to work on A, B, C, and D here. And then I'm going to put up the final answers for this one. That way you will have this to check because we're running out of video time. Okay, if we look at the final answers for this table for Donovan's information, what we will find for this example is that we have a linear function. So we would use the linear regression option, which is option 4, to get the line of best fit. C wants us to predict 7,000 meters. What is the time? So we would plug in 7,000 for y, solve for x in this example, and get approximately 22 minutes. This is an example of extrapolation. And then D, we're finding when x is 17 minutes, and this is within your x values, 5,327.6 meters, interpolation.